Case number 6. Number 6 is 15 times the quantity 4 minus 5b. Am I correct? This is the one I have a question on? Yeah. Is equal to 16 times 4, the quantity. 4 minus 6b plus 10. What do we need to do? Distributed property, what's 15 times 4? 60. 15 times 5? 16 times 4? 64. 16 times 6? 'I don't know why I do a capital B and a lowercase b throughout. I have no idea why I do that. Sometimes I do the capital B because some people think my lowercase b looks like a 6. Okay, so now what do you do? Let's group like terms on the right-hand side. So you have 60 minus 75b is equal to 74 minus 96b. Oh. All right, now what? Move the b's to one side. Which way do you want to move them? Which way? To the left? So we're going to move this over, which changes the sign and makes it positive 96b, which then says you have to take 60 and move it over to the other side. That's negative 60. What's 96 minus 75? That should be 21b is equal to 74 minus 60 is 14. Now the problem I've seen before, for example, the other group, what they wanted to do is just circle that and say that's what your answer is. But what are you doing? You're solving for b, so you're going to have to divide. So you divide both sides by that coefficient of b, which is 21, and then you have to reduce. Okay, number 5 gives you a triangle and it gives you a circle. In the circle, they tell you in the diagram that the radius is 1. In the triangle, they tell you that the base is 3. And they tell you that the height is h. If you read problem number 5, it says the radius of the circle is 1 centimeter, shown to us in the figure. The base of the triangle is 3 centimeters, shown to you in the diagram. The area of the circle equals the area of the triangle. So you know that the area of the circle equals the area of the triangle. What is the height of the triangle? So now you got to start thinking formulas. What's the formula for area of the circle? Pi r squared. That's equal to the area of the triangle, which is base times height divided by 2. What is the radius of your circle? The radius of your circle, let me back up. There's 2 different things you could do going from this point right here. If the area of the circle is equal to half the base times the height, do you know what just the base times the height is equal to? No. What if I put this over 1? What would you do if you saw a proportion? Do you know how to solve a proportion? I know you do. Cross multiply. If I cross multiply, what do you get? 2 times pi r squared is equal to 1 times base times height. If the circle is half of the triangle, then if I double the triangle, I double the circle. That's what I just did. Now, you don't have to do that and put your numbers in there, but it gets rid of fractions for you. What you could do is you could just go ahead and take this right here and say pi r squared equals base times height divided by 2. So you're going to have pi, your radius is 1 squared, equals the base, which is 3, times the height divided by 2. But when you look at it as the fractions, then people get a little confused. Sometimes, some people don't. So you have 1 squared is 1 times pi is just going to be pi is equal to 3h over 2. Do you know how you would solve that right there? What if I told you that 3h over 2 means the same thing as 3/2 h? What would you do to get rid of that 3/2? Divide by what? By what? We divide by the coefficient, right? Yeah. We're taking h times 3/2, so to get rid of it, you divide by 3/2. So I want to divide by 3/2 because 3/2 over 3/2 is 1. So I also want to divide, let me change the color. So if you have it set up in this format, you divide by 3/2. So if I divide by 3/2, you're going to take pi divided by 3/2. That means pi times 2/3, which is just 2 pi over 3. So your height happens to be 2 pi over 3 centimeters. Now, as I mentioned, that confuses some of you with fractions. If you come back over here, and if I were to just put this over 1 and cross multiply, or say, I'm dividing the base times the height, I'm dividing by 2. To get rid of division, what do? To get rid of division, multiply. It's like multiplying this side by 2, multiplying this side by 2. You get that 2 pi r squared is equal to base times height. You put it in the values, you're going to have 2 pi, the radius is 1 squared, equals the base, which is 3, times the height. I think this looks easier to solve because 1 squared is 1 times 2 is 2. You get 2 pi equals 3h. That you look at and how do you solve for h? You have to divide by that coefficient, so you divide by 3. And we got the same answer we had over there, which is 2 pi over 3 centimeters. Two different ways to go about solving it. One, you're looking more at fractions. The other one, you get rid of the fraction before you put your numbers in. Good question. Did you get an answer? You know 8 is wrong? I erased it because I was wrong. 3 times negative 2x minus 3 minus 2 squared is equal to the opposite of negative 3x minus 5. Minus 2. All right, what's the first thing we need to do? Somebody help her. What do we do first? Distribute. So we're going to distribute this 3 through, which is going to give you negative 6x minus 9. What do you know about this next term when I look at this? Your base is 2, not negative 2. So we're going to have minus, and 2 squared is 4. It's not a plus 4. Plus 4 would make the negative 2 be in parentheses. That's equal to, what happens when you have a negative in front of your parentheses? You change the signs. You multiply that through. Negative 1 times negative 3 is 3x. Negative 1 times negative 5 is positive 5 minus 2. Question? Some of you do this, I don't know. We want to simplify both sides, so we look at the left-hand side and we say, is that simplified yet? No. What do you need to do? Group like terms. So you get negative 6x. What's negative 9 and negative 4? Negative 13. On the right-hand side, we need to group like terms. So you get 3x. 5 minus 2 is 3. Now what? Move them over. I don't know which way you want to move x. If I move it over, it becomes negative 3x, which means you have to move the negative 13 over to the other side, and it becomes positive 13. You get negative 9x equals 16. Now what do? Divide by negative 9. So what is x equal to? Negative 16/9. Well, 20. Okay, so the question asks you to simplify by adding like terms. When you look at those, and none of those terms seem to be the same, but we can simplify each term itself and then compare them. And it's best, you can either make them all positive exponents or move everything into the numerator and compare your exponents. So if we look at the first one, I tend to like to move them up to the numerator. So you have 3x. If I move the y up, it becomes y to the negative first. Minus 7. If I simplify the second term, I can group those x's together because simplified, each variable occurs only once in a term. So if you have x squared next to the negative first, that's the same thing as x to what power? To the first. Y to the negative first. Oh, if I look at it, what do you notice about those first two terms? Are they like terms? Yes, you have x to the first, y to the negative first in both terms. If you look at the last term, you have 2. The x exponent is to the negative first, and you get y to the positive first. Now, if you want to put those ones there, you can. They're understood to be there. So your like terms are just the first two terms because they have the same base, or the same variables raised to the same power. So what do you do with those two terms? Just combine the coefficients. What's 3 minus 7? -4. Can I change the slide?
Yeah.
17. We have X. Oh. Okay, the first thing I always do is when I look at the problems that look like this, I separate the numbers, the numerical part, from the variables. Is there a number that is your base, not an exponent, but I just mean a base? It's 2, right? Is that 2 being raised to a power?
Yes.
Yes, it is, because it's in parentheses with this as an exponent. That's the first thing I take into consideration as I say, okay, I have a 2 to the -2 power. If you look at just 2 to the -2 power, change the color of that. So if I look at 2 to the -2 power, what's the value of that? No, close. You take 2 and you square it, which is 4, but what's the negative exponent mean? Flip it. So instead of 4, what do you get? 1/4. That's going to be part of my answer. 1/4 will be part of my answer. Now I go back and I look at the variables. And if I look at the variables, I know that x squared, y, and x are all being raised to that -2 power. When you take a power, raise it to a power, what do you do to those exponents? What operation? Multiply them together. We're going to multiply them together. So what's 2 times -2? -4. This is a 1. 1 times -2 is -2. X is to the first. You take that to the -2 power. You get x to the -2 power. And then you have that y right here that I'm going to put right here at the end. In the denominator, what is anything to the 0 power? 1. Now it's the number 1. That's going to occur down here, but you multiply it times the 1/4. Don't add it. You multiply it. So that's not going to change my answer. We look at the next part. So we just have x, and y squared. If you forget what happens when you take a power and you raise it to a power, you have parentheses right there. What operation does parentheses designate? Multiplication. So you multiply those exponents. Now that I've taken care of the powers, now I just have bases that I'm multiplying together. So you do what to the exponents? What do you do to the exponents now? Add them together. So if I add the x exponents, you get x to the -6, y to what power? -1. In the denominator, you get x squared and y squared. Oh, that 2 runs into my y and it does not look good. Okay, now what do you do? You move them up. When you move them up, what does that do to the sign? Makes it a negative. It changes the sign. And now if you group them together, you have x to the what power? -8, y to the -3rd. Do they ask you to write it as positive or negative exponents? What problem is this one? 17. Write all exponential expressions in the numerator. I could have turned around and looked at the board to see it was problem number 17 instead of looking at my book. Trying to figure out which problem it was. right? So write all exponential expressions in the numerator. That does not mean move this part up. We don't move that up. What you want in the numerator are your variables. Are your variables in the numerator when we say x to the 8th, y to the negative 3rd? Yes, they are. So you write your answer as x to the negative 8th, y to the negative 3rd, all over 4. Do not make it negative 4 or anything of the sorts. It is 4 to the negative 1 power is what it is. And we don't say, if I talk about a quarter of an inch in shop, we don't say 4 to the negative 1 inch. Can you go cut that board 2 and 4 to the negative 1 power feet long, inches long? We don't say that. Now it is the same thing as this, but you have to be careful how you write this so that it doesn't look like the x and the y are in the denominator. If you put that 1/4 out in front, because I can tell you if you write it this way, if you show your 1/4 that way, and then put x to the negative 8th, y to the negative 3rd, this is all in the denominator the way you have it written there. So I would strongly advise not to do that. And I would just keep it as this format right here. Work with those variables first. Or the numbers, I mean. I work with the numbers first. So what's the number part on problem number 18? If you look at 18 and you just look at the numbers, you have a 3 in the numerator. What do you have in the denominator? You have negative 2 raised to the negative 2 power. Is that it for just the numbers? Yeah. What is negative 2 squared? Positive 4. What's the negative exponent say? Move it up. So I'm going to put 4 into the numerator. Once again, you multiply those two numbers together. Do not add them. So in your answer, you should have a 12. Number-wise, you should have a 12 involved for problem number 18. So on number 14, what about number 14? Yeah. Number 14. Number 14, number-wise, just look at the numbers. What do you have in the numerator? 3 to the negative 2 power, right? Because that 3 is being raised to that power. It's in parentheses with the exponent outside of it. What about the denominator? What's the numbers in the denominator? You have 9 to the negative 2nd power. So I do this. What is 3 squared? 9. The negative exponent says, move it down. So that puts the 9 there. You look at the second one, or the denominator part. You have, what is 9 squared? 81, and move it. What's 81 divided by 9? 9. So the number part of your answer for problem number 14 should involve a 9. Are we okay with the variables on those? 18 is not done. There's more to that. That's just the number part. And the same thing for the other one. Do you have an answer for 18? No. I said we want to break it down and look at the individual parts. So if we go back to 18, we've looked at the numbers. Now you need to look at the variables. In the numerator, you have x squared. What else do you have? X, y squared, x to the negative 4th. In the denominator, you are going to have x squared y raised to the negative 2 power. And then that's it. There's your variables. So if you look at it, the first thing you want to do is, do you have a set of parentheses with something being raised to a power? Yep. That occurs right here, right? So if you do that first, what do you do to those exponents? What do you do to these exponents right here? No. What does parentheses tell you? Multiplication. So you're going to have x squared, x, y squared, x to the negative fourth in the numerator. And the denominator, when you see those parentheses right there, you multiply those exponents. So you get x to the negative fourth, y to the negative second. Now you want to simplify. To simplify, what are you going to do to these exponents now? Add them together. So there's a 1, so you get 2 plus 1 is 3, minus 4 is negative 1. You get y to the second. In the denominator, we just have that x to the negative fourth, y to the negative second. What do you do from there? Move them up, which makes it x to the fourth, y to the second. We know my answer has this numerical value of 12 in it. If I add the exponents now in this part right there, you're going to get x to what power? To the third and y to the fourth. There's your answer. That is for 18. 18 should be 12x to the third, y to the fourth. I did not finish 14. I just gave you what the number part was. What's the x exponent going to be in the numerator? We took care of the numbers, correct?
Yeah.
So number 14, now we need to look at the variables. If you look at the variables, you have this x squared being raised to the negative 2 power. Then you also have y to the 0, y to the 5th. If you look at the denominator, inside those parentheses, you have y, that is being raised to the negative 2 power. Then you have y squared, x to the negative 3rd power. Simplify. What does this right here become? See your parentheses? What do you do to the exponents? Multiply, so you get x to the negative 4th, y to the 5th. I'm just going to go ahead and say 0 and 5 is 5. Down here, this is what? Y to the negative 2nd. Then you have y squared, x to the negative 3rd. So the numerator is x to the negative 4th, y to the 5th. What's the denominator become? You add these together and you just get y to the 1st, x to the negative 3. What do you do next? Bring them up, which makes it y to the negative 1st, x to the 3rd. That gives you x to the negative 5th. Oops. Added the wrong ones together here, or sign or something. You get x to the negative 1st, y to the 4th, and we talked about the numerical part, which is 9. What did you say, number 1?
Yeah.
Number 1, if the radius of a circle is r centimeters, what is the area of the circle? What's the formula for area of the circle? Pi r squared. What's the radius? What do they tell you the radius is? 2. Nope. If the radius of a circle is r centimeters, what is the area of the circle? Well, the area of a circle with the radius of r is pi r squared. You have 2 answers to this. There's the first one. That's the first question mark. If the radius is increased to 2r, what is the area of the circle? If I increase it to 2r, the radius is now 2r. Pi r squared. What's 2r squared? What's 2r times 2r? R times r is r squared. So the area of the second circle when the radius is 2r is 4 pi r squared. There's one way you can get rid of fractions if you don't like working with fractions. Or you can work with fractions. I don't care which one you do. That's probably up to you. Do you want to work with fractions or not? I can tell you if you do not, you're going to get some large numbers. Okay, work with fractions. If I work with fractions if you don't want to work with fractions, you have to change 4 3/8 as an improper fraction. Then you got to get a common denominator between 8, 7, and 5. Which is perfectly fine to do. If not, you want to isolate the x, right? So to isolate the x, we need to move, the x's are on one side, we need to move the constant over to the other side, which makes it what? Negative 2/7. So if I do that, I have negative 3/5 x is equal to, you get a common denominator. What's that common denominator? 56, so you multiply by 8 to give you 16. 56, you multiply by 7 to give you 21. What's 21 minus 16? So far, I think you get 4 and 5 over 56. Correct me if I'm wrong for any of you that have already worked through this. Now what do? I want to get rid of this negative 3/5, so what do? Divide. So I have to divide by negative 3/5. Divide by negative 3/5. How do you divide fractions? Keep, change, flip. First thing has to be what? Improper fraction. So you got to take 56 times 4. Add 5. So you're going to end up with 229 over 56. Keep, change, and flip. Is your answer going to be positive or negative? Negative. What do you get when you multiply those two together? You get a big number. You got to take 229 times 5.
For a memory, I get 1,145.
10, 14. Yep. So you get negative 1,145. And if you take 56 times 3, you're 168.
Number 2.
Which one?
10.
Fractions again. What do we do with fractions? This one, I could show you the other method because this one's actually a nice way to do it if you use the other method. I don't know. Do you want the other method or you just want to work with fractions? The other method, if you write it as I'll just set it up here just quickly. You get 13/3, write it as improper fractions, minus 1/2 is equal to 17/5. What's the common denominator between those three? Between 3, 2, and 5, what's the common denominator? 30, right? So I'm going to take both sides of my equation times 30. If you do that, you have to use the distributive property on the left-hand side. 3 goes into 30 how many times? 10. You multiply by 10, you get 130x. 2 goes into 30 how many times? 15. 15 times 1 is 15. 5 goes into 30 6 times. 17 times 6 is, I believe, 102. Then solve that problem. If not, we come back over here. Both sides are simplified, so I want to move the negative 1/2 over, making it positive 1/2. So you have 4 1/3 x is equal to, you get the common denominator of 10, which makes it 5/10. This becomes 4/10, which gives you 3 9/10 when you add them together. I do believe. So what do you have to do now? Divide by the coefficient. So you're going to divide by 4 1/3. So come over here and say divide by 4 1/3, which means keep, change, flip, put them as improper fractions first. So you have 39/10 divided by 13/3. Keep, change, flip. 13 goes into 39 how many times? 3, which gives you 9/10. Don't let that equal sign throw you off there. Number 4 has several parts to it. The length of each side of the square is 6 centimeters. What is the area of the square? So you know this. They give you a square, and they say the length of each side is 6. What is the area of the square? Area of the square is equal to 36, is it in centimeters? Square centimeters. There's the first answer. The circles have equal areas. What is the radius of a circle? Well, if I put 3 circles here, how many radii go across the circle? Here's a radius, right? And here's a radius. 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 You have 6 of them. So what's the length of just one of them? What? 1.
Oh, yeah.
So the radius is 1 centimeter. That's the next question. What is the area of the shaded portion of the figure? Well, the shaded portion of the figure is all of this right here, which is found by doing what?
Area of the base minus the area of the circle.
Area of the square minus the area of the circles. So I got to take the area of the square minus 9 circles. Well, what's the area of your square? 36. If the radius is 1, what's the area of one circle? The area of a circle is pi r squared, which is pi times 1 squared, which is just 1. So the area of one circle is what? Area of one circle is what? 1 pi. How many of those circles do you have? 9. You have to subtract 9 of those. Oh my goodness, I hope this saves.